Here is a pendulum, a ball hanging on a string, swinging back and forth. The vector represents the centripetal acceleration of the ball. This acceleration causes the ball's velocity to change direction along the circular path. The direction of the centripetal acceleration is always perpendicular to the ball's path. The magnitude of the centripetal acceleration depends on the ball's velocity. The larger the velocity, the larger the centripetal acceleration. At the top of the swing, where the ball's velocity is momentarily zero, the centripetal acceleration is also zero. There is no tension in the string at that moment. At the bottom of the swing, the ball's velocity reaches a maximum value. Accordingly, the centripetal acceleration also has a maximum value there, as well as the tension in the string. The vector now represents the tangential acceleration of the ball. This is the acceleration which causes the ball to speed up and slow down. It points along the ball's path. On the way down, the tangential acceleration points in the same direction as the velocity, causing the ball to speed up. On the way up, the tangential acceleration points in a direction opposite that of the velocity, causing the ball to slow down. The tangential acceleration is caused by gravity. At the top of the swing, the tangential acceleration is pointing downward, the same direction as the gravitational force. At this instant, the tangential acceleration is equal to the downward acceleration of gravity. Remember that the tension in the string is zero here, so the only force acting on the ball is gravity. As the ball swings downward, the component of the gravitational force along the path becomes smaller, reducing the tangential acceleration. At the bottom, both the force of gravity and the tension in the string are vertical. There is no horizontal force, so the tangential acceleration, which is horizontal here, is zero. The ball has its maximum speed here. It is exactly between speeding up on the way down and slowing down on the way up. It is neither speeding up nor slowing down at this point. The net acceleration is the vector sum of the tangential and centripetal accelerations. At the top of the swing, the centripetal acceleration is zero, and the net acceleration is tangential, pointing downward. At the bottom of the swing, the tangential acceleration is zero, and the net acceleration is centripetal, pointing upward. As the ball swings from the top to the bottom, the direction of the net acceleration rotates through 180 degrees, from downward to upward. As the ball continues to swing back up again, the direction of the net acceleration rotates an additional 180 degrees, 360 degrees in all, as the ball swings from one top position to the other. So if I click on this button, the simulation shows just the centripetal acceleration. If I click on this button, the simulation shows just the tangential acceleration. And if I click on this one, it shows the resultant acceleration. How cool is that?